Now we look at the third problem on inference about the proportion. So to study whether a coin is fair or not, a gambler tossed a coin 10,000 times and obtained 5,076 heads. Okay? So for the first part, based on the situation provided, state the null hypothesis HO and the alternative hypothesis H1. So here, let P be the proportion of a head showing up. If this coin is fair, then that means the proportion of a head showing up is equal to the proportion of a tail showing up. That means our null hypothesis HO will be P equal to 1/2 versus the null hypothesis versus the alternative hypothesis, which means this coin is not fair. That means the proportion of a head showing up is not equal to 1/2. Or say in another way, the proportion of a head showing up is not equal to the proportion of a tail showing up. Okay, so this is the statements of the null hypothesis and the alternative hypothesis. And next, we're going to calculate the z-test statistics and the p-value. Firstly, for the z-test statistics, we have z equal to the observed proportion. In this case, that is 5076 divided by 10,000 minus p0, that is the proportion appears in the null hypothesis, that is 1/2, divided by square root of p0, that is 1/2, times 1 minus p0, that is 1 minus 1/2, divided by n, and our n here, that is the total number of trials, that is 10,000. And if we do the calculation, this is actually equal to 1.52. So the z-test statistics is equal to 1.52. And then we're going to find the p-value. Again, remember the p-value is the probability of observing data as extreme or more extreme than what we have observed in the direction of the alternative hypothesis H1 when the null hypothesis HO is true. So here, our alternative hypothesis is P not equal to 1/2. That is, we have a two-sided test. So when calculating the p-value, we'll have to calculate the probability of the both sides. So that means we're going to calculate z greater than 1.58 or z less than negative 1.58. So here we have a two-sided test. So the p-value will have to consider about both directions. So basically this is equal to 2 times the probability of z greater than 1.52 by using the symmetry of the normal distribution. And then this is equal to, by using your calculator or by using the normal table, this is equal to 2 times 0.0643, and this is equal to 0.1286. Okay, so this is the result for the p-value, and this is the result for the z-test statistics. Alright, now for the third part, what is your conclusion of this problem at 5% significant level. State your conclusion clearly in both statistical meaning and contextual settings. Okay, so we can see that our p-value, the p-value is 0.1286 greater than the significant level, that is 0.05 or 5%. And we fail to reject HO. And this is our statistical conclusion. And in the contextual setting of this problem, we conclude that at 5% significant level, there is evidence that this corn is fair. Okay? Alright, this is the third part of this problem. Finally, we'll look at the fourth part of this problem. We're going to construct a 95% confidence interval for the proportion of a head showing up. Alright, remember the formula for the confidence interval for a proportion is in the form of p hat, which is the observed proportion, plus or minus z sub alpha over 2 times the standard error of p hat, S-E p hat. Okay? So to evaluate this confidence interval, we will have to find p hat. We will know z sub alpha over 2 and the standard error of p hat. So by the previous part, we know p hat is equal to 5076 divided by 10,000, and this is 0.5076. And the alpha is equal to, the significant level is 5%, and then the 0.05 divided by 2 is equal to z sub 0.025, and this is 1.96. And then the formula for the standard error of p hat is given by square root of 0.5076 times 1 minus 0.5076 over the total number of trial, that is 10,000 in this problem, and this is equal to 0.0050. And then we can put all pieces into the formula, and the confidence interval is p hat 0.5076 plus or minus 1.96 times 0.0050. And if we do the calculation, this is 0.4978 to 0.5174. Okay, this is 5. And this will be a 95% confidence interval for the proportion of a head showing up. And this is the end of this problem.